Hey guys, it's Miss Beckham. I am out again today, so I am going to be giving you guys some notes through Zoom again today. So for today, you need to get out the notes that I passed out to you guys on yesterday. They're called limiting and excess reactant notes. I think it's just a front and back page, and we're going to be filling in those notes. So if the sub needs to pause it for a second to make sure everybody gets out those notes, go ahead and get out your notes before we fill these in. And we did an intro activity yesterday on this topic about the limiting reactant. And so some of this should be making sense to you as we do it. And I want you to be thinking about the s'mores example that we did yesterday while we're going through this, okay? So the limiting reactant is the reactant that is consumed first in a chemical reaction, limiting the amount of product formed, okay? So think about the different examples that we did. If you have a random amount of graham crackers, marshmallows, and chocolate chips, one of them is going to be your bottleneck. They're going to be the ones that are consumed first, and they're called the limiting reactant. The excess reactant are the other reactants that is not used up completely. Not used up completely in a chemical reaction. Okay? So we can draw a picture to kind of show an example of this with this example of a reaction right here. We've got carbon and oxygen making CO2. So let's pretend that we have 5 carbons. We'll make carbon black. 1, 2, 3, 4, 5, okay? And let's say that we have 7 oxygens, and oxygens is like O2, right? So they're separate little molecules here. 1, 2, 3, 4, 5, 6, 7, okay? So if you have 5 carbons and 7 oxygens, how many CO2s can you make? Okay, how many CO2s can you make? Well, each CO2 has 1 carbon, right? So each of those 5 carbons are going to be part of each CO2. So I'm kind of starting to draw. Okay. And then each one of them needs 2 oxygens, and we're going to use these molecules for that. So they're going to pair up. Let's maybe put them like this, CO2. All right, have we used all of our oxygen atoms here? Well, we used one set, 2, 3, 4, 5. We used 5 pairs of oxygen atoms, 1, 2, 3, 4, 5. So how many oxygens were not used up? Well, there were some leftover oxygens that were not completely used up. There were actually 2 when you count them up, right? So there, I'm going to write that over here. There are 2 oxygens, 2 oxygen molecules left over, and we call that the excess reactant. They are the excess reactant, right? So which reactant is the excess reactant? The answer for that would be oxygen, and we drew the remaining molecules over there to the side, right? So how do we determine the limiting and the excess reactants for a chemical reaction? The answer to that is stoichiometry. We're going to do the same thing that we did before, but we're going to basically go one step further, okay? So we're going to compare the reactants that we have to see which one produces the least product, if that makes sense. Just like we did with the s'mores, we figured out, like, okay, if you have 34 graham crackers, you can make, blanking, 34 divided by 2, so 17, you can make 17 s'mores. But if you only have like 13 marshmallows, then the 13 marshmallows are your limiting reactant. So you see which one produces the least product, and that is the most that you can make. Because whatever you have in the least is your bottleneck, right? So let's try a problem together. Thankfully on this problem, if you notice, the reaction is already given to us. So we don't have to draw the reaction or write the reaction, and we also don't have to balance the equation, because if you notice, it's already given to us. So let's go ahead and read the problem. If this reaction is run with 6.25 moles of HCl and 2.75 moles of calcium hydroxide, which substance is the limiting reactant? Then calculate how much excess reactant is left over. Okay, so when you have limiting reactant problems, what you're going to do, and I'll show you here, you're going to choose, they're going to give you two pieces of information. And we're trying to figure out, okay, which one is the one that limits us, right? So you can choose arbitrarily one of the reactants. I'm going to choose the 6.25 moles rather than the 2.75. I'm just going to start with this one, okay? You're going to convert that to moles of the other reactant. So what is our other reactant? We have HCl right here, right? So we're going to be converting to moles of calcium hydroxide. And if you're making a note for yourself, it's whatever the other reactant is. Okay. And we're going to see if we have enough of it. Okay. And I'll kind of explain what this means. So first, we're going to write down what we start with, 6.25 moles of HCl. And I want you to convert that and figure out, okay, if I put in 6.25 moles of HCl, how many moles of calcium hydroxide do I need in order to, how many do I need in order to make the reaction happen completely? All right, so I'm gonna have everybody try this on your own. So the substitute compose, convert to moles of calcium hydroxide using the same stoichiometry mole map that we've had before. Put your finger on where you are and then convert over to moles of calcium hydroxide. So go ahead and pause the video. All right, so you should have converted to moles of calcium hydroxide. So what we want to get to goes on top, and what we want to cancel out goes on bottom. And we're going to use the mole ratio to get there. So if you notice, we're going to use the coefficients in the balanced equation. So look at the coefficient in front of calcium hydroxide, and there's an invisible 1 there. Look at the coefficient in front of HCl, and there's a 2 there. Our moles of HCl will cancel out. And so it's just going to be 6.25 times 1 over 2. So go ahead and calculate that if you haven't. 6.25 divided by 2. 3.125 moles of calcium hydroxide. Okay, so here's where I need you to apply your thinking, all right? What this is saying is that if you have this much HCl, you will need this much calcium hydroxide. This is what we need, okay? So now, how much calcium hydroxide do we have? Go ahead and write that down. How much do we have when you read the problem? We have 2.75 moles of it, okay? So if what you need is more than what you have, then this is going to be what limits us, right? If what you need is more than what you have, right, that will be your limiting reactant. If what you need was less than what you have, like you needed less and you had more of it, then that wouldn't be your limiting reactant. It would be the other one, right? So we know that our limiting reactant, I'm going to say limiting reactant LR, is calcium hydroxide, because we need 3.125 moles to complete the reaction. This is just me processing it. You don't have to write this down, but it kind of helps for some people. But we only had 2.75. Right? So that answers the first question. The second question says, calculate how much excess reactant is left over. Okay. 1 second. All right, now we need to answer the second question. Calculate how much excess reactant is left over. Okay. Well, we need to figure out how much is going to be consumed, okay? Because HCl is going to have some leftover amount, but it's asking how much, okay? So we're going to use the limiting reactant for this part. So when you are doing the excess, figuring out how much excess, you're going to use the limiting reactant. So the calcium hydroxide was what limited us. So we're going to write down what we started with in calcium hydroxide. We started with 2.75 moles, and we know that all of that is going to be used up because this is what limits us. So we're going to convert to moles of HCl, and we want moles of calcium hydroxide to cancel out. And we're going to fill in that information from the reaction here. So there's a 2 here and a 1 here. So what's 2.75 times 2? Getting 5.5. 5.5 moles of HCl. So we know that this is what limits us, right? And so if you put in 2.75 moles of calcium hydroxide, you would need to use 5.5 moles of the hydrochloric acid. Okay? Okay, so we started with 6.25 moles of HCl, and we know that we're going to use 5.5. So if it asks how much is left over, we're just going to subtract to get our answer. 6.25 minus 5.5. And we're getting 0.75 moles left over. If the question said how many grams, we would have to convert that to grams by multiplying by the molar mass. The question didn't specify, it just said calculate how much excess reactant is left over. Because it didn't say it had to be in grams, I'm going to make it easier on myself and just leave it in moles. Okay? So that's kind of how you do limiting reactant problems. We're going to do more practice together. Okay, so let's just look at the next one here. It says you try one. If 95 grams of copper sulfide and 55.7 grams of oxygen are available, which reactant is the limiting reactant? So I'm going to let y'all start it and then pause it. So remember, you're going to choose one of the reactants. So you might want to go ahead and choose just the 95 grams of copper sulfide. And you need to get that to either moles or grams, whichever one you want to do, of your other reactant. Okay? The other reactant is what? The oxygen, right? So get those grams all the way to moles. Get out your mole map and put your finger on where you're starting. You're starting with grams of copper sulfide, and you're trying to get to moles of oxygen. So I'm going to have, actually, because we're starting with grams and grams, you could go to moles, but I'm going to encourage you to go all the way over to, it'll help you out. Well, hold on. This is all that it's asking here. Yeah. Yeah, it's just asking which one is the limiting reactant. So you could go all the way to grams if you wanted to, but you don't have to. So I'll show you guys both ways in a second on if you prefer. So go ahead and pause the video and at least get to moles of the other reactant. All right, so hopefully got your grams. So because we're in grams, first we need to get from grams of copper sulfide to moles of copper sulfide. And the only way to do that is to use molar mass. And you should have gotten something close to 95.61. It's probably going to be a little bit different than mine. I'm using a periodic table online to do it. So your periodic table might be a little bit different. Okay. And so we got to moles, and now we need to get to moles of oxygen. And we would want moles of CuS to cancel out. So when you see moles and moles, where do you get that information? You get it from the coefficients in the balanced equation. So I'm getting 3 and 2 because you see those are the numbers in front. Okay, so you could stop here, like I said, and get to moles. And if you did that, your answer should be about 95. 1.49 moles of O2, okay? But because this problem is in grams here, we're going to want to get to grams. So if it gave it to us in moles, we could stop here, but we don't really know because it starts with 55.7 grams. So we're going to go one step further and get it to grams of O2. Okay, and we're going to put moles on the bottom. So the molar mass of O2 is 16 plus 16, right? So we're going to put 32 grams on top and 1 mole on bottom. So we are going to go one step further and multiply it. So I'm getting 47.69 grams of O2. Okay, so what that means is that if I put in 95 grams of copper sulfide, I need 47 grams of O2. What do I have? I have 55.7 grams of O2. Okay, so I need 47.69 and I have 55.7. So I have leftover oxygen. Okay, so which one is going to be my limiting reactant? It's going to be the copper sulfide. So CuS is the limiting, is the limiting reactant. Okay, because I needed 47.69 grams to complete that reaction and I had leftover oxygen. So therefore the one that limits us has to be the other one. Copper sulfide is the limiting reactant. Okay. All right, so we're going to flip to the back and do some more practice here. Okay. And thankfully, these are all written out for us. We're just going to read it together. What mass of barium nitrate can be formed by the reaction between 75 grams of barium carbonate and 35 grams of nitric acid? Okay, so it's asking if you have this much barium carbonate and this much nitric acid, how much barium nitrate, or like we did, how many s'mores can you make? Well, first we need to figure out which one limits us. Okay, we got to figure out which one limits us. And because everything is in grams, we're probably going to want to get all the way over to grams. Okay, so we got to figure out which one is our limiting reactant in order to figure out how much barium nitrate we can make. So we're going to choose one of them randomly. So let's do the barium carbonate, 75.0 grams of barium carbonate. And remember, we're going to convert that over to grams of the other reactant. So I'm going to have y'all pause and do this one. Convert that to grams of the nitric acid, HNO3. Go ahead and pause, and we'll do it together in a minute. So first off, we're going to divide by the molar mass of barium carbonate. You've gotten about 197 grams per mole. Then we're going to get over to moles of B using our mole map. And our B is HNO3. And our A is barium carbonate. Now we're going to use the coefficients in the balanced equation to get there. So I get 2 and 1. I'm getting those from these coefficients in the balanced equation. And now I need to get to grams of HNO3. I need the moles of it to cancel out. We're getting about 63.01 grams per mole. Okay, so when you calculate that out, I want everybody to try to punch this in their calculator if they haven't yet. Hold on. All right, so I'm getting 47.89 grams of nitric acid. This is what we need, okay? So which one is our limiting reactant? We need 47.89 grams of HNO3 to use up this 75 grams. But we only have, how much do we have? We have 35 grams. When you look at the problem, I'm getting it from right there, right? So that means that the nitric acid is what limits us. the HNO3 is our limiting reactant. Okay, so now we can actually answer the question. It says, what mass of barium nitrate can be formed by the reaction here? Well, if we know that HNO3 is what limits us, then you're going to use the limiting reactant to figure out how much product you have. Because if you think about it, if you had, 100-gram crackers, but only 13 marshmallows, you would use the 13 marshmallows to dictate how many s'mores you would get, right? So we know that HNO3 is what limits us. So we're going to use that information, the 35 grams, to figure out how much product we get. We are not going to use the 47.89 grams because that's what we theoretically need, but we don't actually have that, right? So we're going to use what we have. When you figure out how much product, you're going to use the limiting reactant to get you there. So we're going to convert that all the way over to grams of barium nitrate because that's what it's asking for. So I want the sub-deposit video again and convert grams of HNO3 all the way over to grams of nitric acid using your stoichiometry map. First step, get HNO3 to moles using molar mass, and its molar mass we already calculated was 63.01. Second step, get to moles of B, which it's asking for barium nitrate. And we want moles of Ra to cancel out. This is moles right there. So when we look at our moles up here, I'm seeing 1 mole and 2 moles. I'm getting that from here and here. I'm putting them just right where they go, right? Last step is to get to grams of barium nitrate because it said what mass, not how many moles. And I would want the moles of barium nitrate to cancel out. So how do we get this information? Where do we get how many grams are in a mole? We get that from the periodic table. So you need to look up the molar mass of barium nitrate, which hopefully you did. You add them all up and you multiply those out. Okay, and you should have gotten 261.34 or something close to that. Okay, and then you should have calculated it. I am getting 72.58 grams, and that would actually be how many significant digits we would need. 72.58 grams is how much barium nitrate we would have. Okay, so we finally answered the question. And in summary, what we did was we figured out what our limiting reactant was by comparing what we need with what we have. Then we used our limiting reactant to convert to grams of our product, which is what it basically asked for. The next question says, calculate how much excess reactant is left over. So what is our I'm going to write above it, but what is our excess reactant? I'm going to write up here if y'all can see. Our excess reactant was not the nitric acid, right? That was what limited us. Our excess reactant was the barium carbonate. So we need to figure out how much was used up and how much will be left over. Okay, so we're going to use our limiting reactant to get there. We have 35 grams of HNO3. The question is, how many grams of barium carbonate would be required for that? And then we can subtract. Okay, so because we're trying to calculate how much excess reactant is left over. So we need grams of HNO3 to grams of BaCO3. I'm going to have the sub pause the video and convert grams of HNO3 to grams of barium carbonate. All right, we still know it's still the same molar mass, 63.01 grams. And now we're going to get over to moles of barium carbonate. And we want moles of HNO3 to cancel out. When you look at the coefficients for those two, it's 2 and 1. And then I think we already looked up the molar mass of barium carbonate. It's 197. grams for every 1 mole. And you would just need to calculate it out now. 35 divided by. So I'm getting 54 grams. This is how many grams of BaCO3 we need, right? And we have 75 grams. So we have 75 grams, right? So we're going to do 75. I don't know why my pen is messing up like this. 75 minus 54.8. And that is how much excess reactant we have left over. This was definitely a really full problem, 20.2 grams. Okay, that's how many grams of barium carbonate we'll have left over. Okay, so I know this is going to seem a little bit overwhelming, but the more practice that we do with it, the better. So I would encourage you all to practice these problems and try them on your own. I think this is in chapter 12 of the textbook if you have your textbook at home. I think that everybody checked it out. So here are some tips. When a problem gives amounts for both reactants, you're going to fill in this blank here. That should say, my pen keeps messing up. Both reactants. You need to determine the limiting reactant first. So if you have a problem that gives you 2 gram amounts or 2 mole amounts for the reactants, you've got to determine the limiting reactant first, and then calculate the amount of product using the limiting reactant. That's what we did up there. And the second tip is that if a problem is nice enough to say that one of the reactants is in excess, you should thank that problem, because that is telling you already which one is the limiting reactant. So when a problem says that one of them is in excess, assume the other reactant is the limiting reactant. The limiting reactant. When you know the limiting reactant, I'm going to highlight this. You are going to use the limiting reactant to calculate the amount of product, just like we did up here. When we calculated our product right here, we used the limiting reactant, even though they gave us also the mass of the barium carbonate. We figured out that the other one was what limited us, and so we used that to determine our product. Okay. This next problem here asks for the volume of hydrogen produced from those two things. We are not going to ask you anything having to do with volume. Okay, we might say what mass of hydrogen, like that. So you can cross that out for now, like the volume and the STP. We might ask you what mass of hydrogen is produced from the reaction of 55 grams Mg and 75 grams of HCl. Okay, so let's try this one. Again, they have given us 2 reactants. So we have to figure out which one limits us. So you're going to choose a random one and convert it to grams of the other one, of the other reactant. Okay, so I'm going to have you guys real quick convert that to grams of HCl and compare and see which one is your limiting reactant. So the sub can pause the video again, and you're all going to try this one. So you can look at my work here and double check after you've done it. So 24.3. So check your work there. I'm following the stoichiometry mole map. Hopefully it's getting a little bit easier for you. First, I divided by the molar mass of Mg. And then I put my coefficients in. The 2 here and the 1 here come from the balanced equation. I'm going to double check that I did that right. That seems like a big number, 55.5. Yep. All right. So if we have 55.5 grams of Mg, we would need 166.5 grams of HCl. And this is what we have right here, 75 grams. So we have less than what we need. So HCl is our limiting reactant. Now that we've determined, now that we've determined our limiting reactant, we can answer the question. The question says, what mass of hydrogen is produced from the reaction? So remember, once you figure out your limiting reactant, you're going to use that mass amount to answer the question of how much product. So we're going to start with 75 grams of HCl because that is what we're limited by. We're not limited by the Mg. We're limited by the HCl. And we're going to convert that all the way over to grams of hydrogen. Grams of hydrogen right here. So again, I want y'all to try this one. So the sub can pause it for like maybe 2 minutes and let you convert that to grams of hydrogen. All right, so your reaction should look like this. Got your molar masses in there. Hopefully you got the molar mass of 2.02 for your hydrogen because you doubled it. And I am getting 2.08, but really I should round off to 2 decimal places. So I'll make that 2.1 grams of the hydrogen. All right. So now I've answered my question. I found my limiting reactant because I figured out what I need and what I had, and I determined my limiting reactant. Then I used that number and converted it over to grams of the product that I asked for. And that's it. All right, let's do this last one. Silver nitrate and sodium phosphate are reacted. Okay, fun. So what do you think we're gonna have to do here? We're gonna have to write the equation, okay? So I'm gonna pause it, or I'm not gonna pause it, but I hope that the sub is gonna pause it, and y'all are gonna write the reaction in as small as you can, but like above the stuff you're gonna write. Go ahead and write the reaction. All right, so this is a double replacement reaction. You are swapping partners. And this is exactly what it should look like. So make sure you've got all of your subscripts correctly. Right here, I crossed over my charges, so that's why the 3 went there. That's why we got what we got. And now we're going to balance it, and I'll write this in red. And that should be balanced. That's an NO3 right there, but it got written badly. That is a 3. All right. So now that you've written your reaction, now we can go on with the question. It says that 235 grams of silver nitrate and 197 grams of sodium phosphate are used for the reaction. All right, so we got to figure out which one limits us. But then it says, how many grams of silver phosphate are produced in the reaction? Identify the limiting reactant and determine how much excess reactant will be left over. So we've got to identify our limiting reactant and then use that one to get to grams of silver nitrate. I'm going to pause it, or I hope someone's going to pause it, and I'm going to have y'all try this problem. And it might take like 5 to 10 minutes for everybody to work through, talk it out, talk with your neighbor, do not get on your phones. Think through this problem and work through it using the examples that we did. It's the exact same as the previous ones that we've done. Go ahead and get started. All right, so hopefully you completed the first part, which is identifying the limiting reactant. So I took my silver nitrate randomly. I took the 235. Remember, you could choose either of the reactants. I took the 235 grams of silver nitrate and I converted it all the way to grams of my other reactant. sodium phosphate, okay? So what I figured out was that I would need 75 grams, or about 75 grams of sodium phosphate, right? So now I can figure out what's my limiting reactant. I need 75 grams of sodium phosphate. And how many grams of sodium phosphate do I have in the problem? I have 197 grams. So which one is going to limit me? Well, I've got plenty of sodium phosphate, right? So that means that the other one is going to limit me. My limiting reactant is going to be the silver nitrate, because the one that I did find is definitely has plenty. So this is my limiting reactant, right? So now I can actually answer the question. It says how many grams of silver phosphate are produced. So remember, if you're trying to find the product, you're going to use the limiting reactant one to get you there. So my limiting reactant is silver nitrate. So I look at what I'm starting with, which is 235 grams of silver nitrate. And now I'm going to take that 235 grams of silver nitrate and convert it over to grams of silver phosphate, which is what it's asking for. So now I'm going to pause it, or maybe you guys already have done that, but take a second and convert the silver nitrate over to grams of silver phosphate. Go ahead and pause the video. So silver phosphate is what we're trying to get to, which is the Ag3PO4. We're doing moles B over moles A. And now we need to multiply by the molar mass of silver phosphate. So I'm getting about 418.58 grams for every 1 mole for the molar mass of silver phosphate. So now we're just going to compute that. So I'm getting 193.023 grams of silver phosphate. So what this means is that when we put in our silver nitrate and it's completely consumed, all 235 grams, we're going to get out this many grams of our product. Okay. The next part says determine the amount of excess reactant left over. Okay, so this is going to be a little bit easier because we already have it. So I want you to think about which one was our excess reactant. Okay, the sodium phosphate, and like whenever I'm answering these problems, it helps me to kind of write things out, like our excess reactant. That was the sodium phosphate, right? We had plenty left over. And we knew that was the case because we had 197 grams and we needed 75 grams. So if we needed 75 grams and we had 197, to figure out the difference between it, we would just subtract them. 197 minus 75. So I'm getting 193.0. 193.0 grams. Remember when you subtract, you look at decimal places. So 197.0 minus 75.0 is 193.0. So that kind of concludes our notes for today on limiting reactants. And again, the summary of it is right here on these tips. These tips can really kind of help you. And so what y'all are going to do during this class period is to work on stoichiometry worksheet number 3 right here. So y'all can flip over to that one. Now, some of these are easier than others. Not all of these require you to figure out the limiting reactant. Okay. Because, for example, when you look at number 1, you're trying to find grams of chlorine. And this is what you're starting with, sodium chloride. And do you notice it says with excess sodium iodide? So guess what? This problem was nice enough to tell you that this is the excess reactant. So guess what? You don't have to do that long thing where you figure out if what you need and what you have and which one's the one that's the limiting reactant. You already know that chlorine, this has got to be the limiting reactant right here. So all you've got to do is write your equation for it. And it doesn't really tell you the equation, but you can write it out, right? Because it looks like we've got chlorine gas and sodium iodide. Crossover, right? And they're going to react. So you would double check on your activity series, but I'm assuming that the reaction happens if it's talking about it, right? So the chlorine is going to come in and bump out the iodine, right? The iodine is going to be by itself, and iodine is diatomic. And then you would need to go back and balance. I'm going to let y'all balance, but I'm just kind of getting you started on this worksheet for this one. And for the other ones, it looks like you're going to have to write the equations for this. So what I'm going to tell you is that if you want to double check your work, you can you can go to room 305, the room with the fan in it. I think it's room 305. I said this last time. I'm sorry. The room that Miss Hollis is in, and check your reaction with her, and she'll tell you whether you're right or wrong, and she'll help you with it. She's super nice. So if you need help with anything, go ask Miss Hollis, look at the notes from this unit, and let me know if you need help with anything. Let Miss Hollis know. Also, we are going to have a quiz on limiting reactant tomorrow on Thursday. And I will take a few minutes to go through everything again with you guys in person, because I'll be back in person before you take the quiz, just so you know. And other announcements, your lab is due today. And I think that's it. We're going to have a test on Tuesday of this upcoming week so that you can get ready for Thanksgiving break and not have any tests to come back to over the break. So you're going to take your test on Tuesday, and I have all of that on the board for you, and everything that's due, everything that's for a grade is written on the board for you. All right. So talk to Miss Hollis. If you need to message me on Remind to ask a question, you can. But other than that, keep your phones up and good luck studying.